title on our next blank page in our math notebook is how to use a bar model to show multiplication. That's going to be your title. Some of you might have experience with a bar model, which is awesome. Some of you might not. Some of you might have used something similar and might not realize that actually you do know what this is. You just didn't know it was called that. So on the next blank page in your math notebook, here is your title. All right, a bar model. A bar model can look a lot of different ways in terms of how I can move it, but it very obviously looks like that. Looks like a bar. Draw a bar on your paper. Does not need to be gigantic. That bar can show how much something is worth. It's a way to look at it, kind of like a graph, and be able to say, oh, that side is bigger than the other side. So for instance, I might have a bar model where I have one short bar on top of one long bar. If I said that this was Paxton's bar and this was Aric's bar, what do you think you could think about? What kind of guesses do you have?
Are we allowed to write that?
Yes, that's why I'm writing it. Remember, if I'm writing it, you're writing it. Callie?
Maybe which one weighs more?
Oh, I already know that. Which one would be more?
The on the bottom.
Arts. I don't really know what we're talking about. Maybe we're talking about bug bites. Maybe we're talking about pieces of candy in their lunchbox. I don't know. But we can see that Arts is bigger. That means that it's more than Paxton's, whatever it is that we're talking about.
Yeah.
Does that make sense?
Yeah. So Paxton's is bigger.
So I know that it looks taller. That's just because of bad drawing. We're only looking at length.
Oh. Paxton is.
Sometimes you might have, no thank you, Brogan, you might have seen it like this. Two bars stacked on top of one another, but one of them was split like this.
Yeah. Yeah. That's what you're doing now.
Remember, if I'm writing, you're writing. It shouldn't. That's not what mine looks like. This has a name. When you learned this, probably in first grade or second grade, you very likely called it part, whole. Give me a Me Too signal if you remember something about part, whole. It's okay if you don't.
No. That one's in my life.
We use
You can see it from right here. We use
oh my gosh, a bar,
a graph model
to
help
show
a
value. There's that word again.
Oh.
We talked about value when we talk about equivalency, having the same value, the same worth. We use that bar model to do the same thing. So in my Paxton Aric example, I know that Aric has more, whatever it was, because his bar is longer. In this model, these two bars are the same length. This one is the same length as this one. That tells me that they're the same value because they're the same length. Does that make a little bit of sense?
Yes.
So far, so good? All right, I will pause so that you can copy that down. What does our bar model mean? Let's go to the bar model that you've probably used before, which is a part, whole one. So we're going to draw
write that?
Nope, you don't have to write this, but I want you to draw this bar model. We're going to start off really easy. No, if you have space, use the space that you've got. We're going to start out really easy, Brogan. We're writing. We're going to circle the top bar. Top bar is equal to bottom bar it's this bar right here because those bars are the same.
That's kind of crazy.
Length. So in my part whole model, the way it works is that top bar looks different than my bottom bar. It does. It looks different. But I know that they are worth the same because those bars are equal. They're equal in length. You see that? I bet you know what that bottom bar is worth. Raise your hand if you know what that bottom bar is worth. Not going to be a trick question. Mason?
Probably 5.
Not probably, definitely.
Definitely 5 because 2 to 3 is 5.
Definitely 5. Now, if you use this as part whole, can anyone tell me what are the parts? Because we have a part and a part and a whole. I have 2 parts and 1 whole. Part, whole. What are those parts? Archer?
2 and 3.
2 and 3. Above the 2 and the 3, we're going to put a P. Arik, why do you think we're putting P's up there?
For I don't really know.
Love that honesty. Callie, why do you think we put a P on top of 2 and on top of 3?
Maybe because it's part and part.
It is part and part. If you want to write out the whole word, you can. I'm going to stick with P, but if you want to write out the whole word, go for it.
I'm just going to write P.
So we've got a part and a part, and we need a whole. Where is our whole? Where is our whole? Marley?
In the 5.
The 5. Colby, I'm going to put a W. Why do you think I'm putting a W down by the 5? Yeah, that word whole in this version starts with a W.
Every hole.
Nope, if I'm digging a hole in the ground, that version actually starts with an H. Tricky. So hole and hole have the same sound, but different words.
Oh, so if I'm digging a hole, it's H-O-L-E.
Yep.
If it's like a hole of something,
The whole thing,
it's W
H,
H-O.
E. Get on my brain. You got it, yes. Hang on. This is really helpful because I know that when I add my parts together, I will get my whole. Let's write that equation. I've got 2 plus 3 equal to 5. Duh. Underneath that, we're going to write part plus my part is equal to the whole. When I add those 2 parts together, I get my whole.
I found this upper.
Okay, just leave it there. We'll put it back later. Brogan, what's up, friend? Yep, so just in case we're talking about the same thing, you've probably seen them. Callie's talking about the circle. It is a bar model. It's just a circle model, and we call them number bonds, but it works the same way. I might have 5 here in a circle, and then a 2, and a 3. You might have seen that before. Those are called number bonds. Bowen, if you could stop drawing pictures and writing notes, that would be great. Nope. Well, I mean, you can if you want to. Just know that we're going to use this version, but it's very similar to what you use if you use this version. It just is a different shape. I like the bar model because I can make the bars different lengths if I need to compare. Whereas I can't really compare when they're in circles like that. All right, but that's addition. And just so we know that we can use it with addition, we're going to do this addition problem. Don't write it down. But I'm going to read it, and I want you to write an answer sentence. If you need to turn the page, that's fine. You can turn the page. It says there's 6 packs of Pop-Tarts on the table. Each pack has 2 Pop-Tarts. How many Pop-Tarts are there in? Just kidding. I knew that was weird. I went a slide too far. I pushed too many times. Here's our problem. Sorry about that. I picked 6 flowers on the way to school. On the way home, I picked 2 more. How many flowers did I have all together? Read that one more time. Figure out what am I counting in this problem. If you already know, write your answer sentence. Leave a blank for the number. I'm sure you can figure out the number really easy, but let's practice doing our routine. Bowen, what are we counting in this problem?
Can we just say a random name for them? We're counting flowers.
We're counting flowers. What do you think my answer sentence should be? Mark, you with us? What do you think my answer sentence should be? Think about that question. How many flowers did I have all together? Thank you. I'm not looking for an answer. I want an answer sentence. I want the sentence where our answer is going to go. I don't care about the answer right now.
And I have no clue.
You do have a clue. Ready? I have what? What am I counting?
Flowers.
I have blank flowers. This is an answer sentence. I don't care what the answer is yet. I'll get there. But I have my sentence ready for my answer. Lydia.
I said I picked blank flowers all together. Is that fine?
Perfect. As long as we have blank flowers, we're good.
Me too.
Now we're going to draw our bar model. I'm going to start with a box. In that box, I'm going to put 6. Why do you think I'm putting 6 in that box? Where do you think that 6 is coming from? Axon, where's that 6 coming from? What?
Flowers.
Flowers. It's that very first sentence. I picked 6 flowers. There they are in that box. I'm going to put another box beside it because it says I picked 2 more. There's 2 more. I want to know the total. So I'm going to draw a box that is the exact same length as my 2 that are stacked on top. Because if it's the exact same length, it's the same value. Part plus part equals whole. What's my part? What's my part? Emma? 6. What's my whole? Ava?
Answer?
What's my whole? Yeah, the answer right here. Whole. What's my other part? Owen? 8. What's my other part? 8. It's not. What's my other part? Listen to the word I'm saying. Part.
Oh, 2.
2. Out to the side, I want you to write part plus part equals whole. We already wrote that down. Let's remind ourselves what that is. Now, what's my part?
Why is it so cold in the school? Because it's hot outside.
Penelope, what's my part? 6. Paxton, what's my other part? 2. My whole is box. Do I think that you can solve that problem super fast in your head? Yes. I put a box there as a spot saver. Julian, what is my whole? What's that number? W is my spot saver, but now I'm ready to solve. Solve that problem for us. 8. This bar is worth 8. This box is worth 8. So it does not look like you were writing it.
I already told you that.
How many flowers?
8.
8. This was probably a really easy problem. Good. It should be. Because we're going through how to model it. Let's start with the easies with our model. That way when we get to the hards, we know what to do. We're going to try a multiplication problem now.
Yes, because you don't go straight.
There are 6 packs. This is the one I actually just read ahead of time. There are 6 packs of Pop-Tarts on the table. Each pack has 2 Pop-Tarts. How many Pop-Tarts are there in all? Read it one more time to see if you can figure out what are you counting. We're not solving. We're trying to figure out our unit. What are we counting? Paxton, what am I counting? I'm counting Pop-Tarts. Colby, you want to try and make a sentence? Yes, that was not really a question. How many Pop-Tarts are there in all? There. This is the part where you say it. You got it. There are blank Pop-Tarts. You can use Colby's sentence. If you would rather come up with your own sentence, live your best life. Make sure you have blank Pop-Tarts. That's important. Go and you're writing this down.
Okay.
That was a question. Are you writing this down?
I am.
Thank you. Flip it. Now we're going to make our model. Do I know the total number of Pop-Tarts yet?
No.
No. I'm going to go ahead and draw a really big box. And I'm going to put a W in it because I don't actually know my total or my whole. I know I'm going to have a total, but I don't know what it is. This is the part where you do that. But I do know some things. I know I have 6 packs. I'm going to go ahead and draw 6 boxes for my 6 packs. Actually, what I'm going to do is I'm just going to put my bar and then chop it up like this. Yeah. I made 6 boxes. Why am I making 6 boxes? Mason, do you know why I'm making 6 boxes? 6 packs. Very good. Going, how many are in each pack?
2.
2. So how many do I write in this one?
2.
2. What about this pack?
2.
What about this pack?
2.
This pack?
2.
This pack?
2.
This pack?
2.
crazy part whole, but it's not part whole. It is part whole. Part whole.
I can't imagine doing this.
I know, it would be crazy. So if I'm doing my addition problem, it's not going to be part plus part equals whole. Nope. It is going to be part plus part plus part plus part plus part plus part equals whole. What is that equation? Go for it, Ava.
2 plus 2 plus 2 plus 2 plus 2 plus 2.
Keep going. You got it. Give her some time to think. She's going to get it. Would you like a strategy?
I think I got it.
What is that?
My strategy was 8 plus 2
We're going to think.
plus 2.
Okay, what is it? You got it, Ava. You got it, Ava. It's 12. Can I offer a strategy? Because this is 2s, I'm a really good skip counter of 2s. Are you a good skip counter of 2?
Yeah.
Let's try it. Ready?
2, 4, 6, 8, 10, 12.
So if you see that it's an easy skip count for you, maybe try that next time. Love it. Now, Mason, I know that you're looking at that and you're saying, Miss Miller, I see a lot of groups of 2. I can write another equation.
What I did is I pushed the beginning 2's together, I pushed the middle 2's together, push that together, that's 8, and then 9, 10.
Awesome. Do you think you can come up with a multiplication equation?
1, 2,
Yep, you got it.
2 groups,
How many groups?
6
Equals 12. 6 groups of 2 and 3 equals 12. I don't want to show you. No. Equals 6 groups of 2 equals 12. Now, do you look like this is not making any sense? Are you okay?
Yeah.
Following? All right, we're going to try one more. This is the last one we're going to do, I promise. I have 30 books in my library. We know that's a bold big lie. I have 30 books in my pretend library. I need to sort them equally onto 3 shelves. Can you imagine that? Like a bookshelf has 3 shelves.
Oh.
Right?
1, 2, 3.
There is actually 3 shelves.
Yeah.
Awesome. How many books will go on each shelf? Read that one more time. See, what am I counting? Paxton, you're on fire today. What are we counting? Books. I'm counting books. What's going to be my answer sentence? Connor, you think you can make it?
I have blank books on each shelf.
Yes. This is important. On each shelf. I cannot just put, all right, that I have blank books. Because I actually already know how many books I have. I have 30. This is pretend. So I need that last chunk in my sentence. Excuse me. I have blank books. Oops. On each shelf. That word each is incredibly important. Make sure you have it in your answer sentence. Yes, ma'am, Eva.
You could have 10 books on
Oh, save that thought. I know you were thinking ahead, and I love it. Save it. Save it. You got it, girlfriend. All right, so I've got all these books. I'm going to draw my bar, big bar. Do I know the total number of books that I have?
No.
No.
Yes.
Yes, you have 30.
No. Yes. Yes. Yes.
No?
Yes. You have
Ain't that problem. Do I know how many books I got?
Yes.
Yes. Did it say I'm buying books?
No.
No. Am I throwing books out the window?
No.
Am I giving books away?
No.
So I have 30 books. It tells me that. In that big bar, I'm going to write 30 because I've got those 30 books. So what's happening to those books? They're not going away, but something is happening. Something is happening. Jordan, what is happening to those books?
Put on shelves.
Just like 800 shelves?
3 shelves.
So I'm going to draw my bar on top because I know that my books aren't going away. They're still the same amount of books, but I'm putting them on 3 shelves. I just made 3 boxes. Julian, why do you think I made 3 boxes?
Because there's 3 shelves.
Because there are 3 shelves. All right, let's look at that part plus part equals full. If I were to write this as an equation, do I know my part?
No.
No. Box plus, do I know my part?
No.
Box plus, do I know this part?
No.
Box equals
30.
full. Oh, it does equal 30. Sorry, good call, Lydia.
10 plus 10 plus 10.
If I think of this as a multiplication problem, this is tricky. Who thinks I can come up with a multiplication problem with what I've got? Don't put any numbers that aren't there yet. Marley, think you can do it?
You could do 10 plus 10.
That is not a number that I've got. This is what I got. I got boxes and I got 30.
You could part the 30 3 times and get 10.
Okay, so I'm hearing I have 3 groups of what?
Books.
Box.
10.
Box. I have 3 groups of box.
3 groups of 10.
No, 3 groups of box. I don't have a 10 yet. Right now I got 3 groups of something.
You could do
Save that thought, Marley. I can write a division equation. How many books did I start with, Eva? 30. I put them into groups. That's what that symbol means. Paxton, how many groups did I put them in? 3. And that equals how many in each? That would be my box. I have 2 equations, really 3 equations, that I could use to solve it. This is where the cool part comes in. You get to say, which one makes my brain happy? For a lot of you, you're sitting there like, hey, I know 3 times something equals 30. I could figure that out. For some of you, you're thinking, okay, I got 30 and I'm putting them, 1 for you, 1 for you, 1 for you. 1 for you, 1 for you, 1 for you. You get to pick. Ava? It can be 3 tens. So Ava, I'm guessing this equation, 3 groups of 10 equals 30, made your brain happy. Yeah. Same.
how many mallets?
We're going to use bar models a lot. I want to challenge you today to try and use a bar model. It's okay if you don't get it right. We're going to do a task. This task, you're not going to write anything down yet. It's about a group of grasshoppers. Raise your hand if you've ever seen a grasshopper before. Does anyone know what color grasshoppers are? Archer, what color are grasshoppers? They could be green or brown. They kind of blend in with grass.
Or black.
That makes sense. Yeah, they kind of just blend in with the grass. So I see a group of grasshoppers on the ground. I see some legs, some grasshopper legs. How many grasshoppers are there? What are you wondering? I'm looking at grasshoppers. I see the little grasshopper legs. How many grasshoppers are there? What are you wondering? What are you wondering? Leah, what are you wondering?
How many grasshoppers that there are, so I know how many legs, like what legs to count.
Yeah? Samara? Sure. How many are in this group? That might be helpful to know. Archer? I probably need to know how many legs are even on a grasshopper. Does anyone know how many legs are on a grasshopper? Emma?
2.
Not 2. How old do you know?
4.
Not 4. I'll give you a hint. A grasshopper
6.
is an insect. And an insect has 6 legs.
Because it's back legs.
No, thank you, Brittany. So let's say I look down and I see 6 legs. Could that tell me how many grasshoppers there are?
Yes, you can count by 6.
How many grasshoppers would that be? If I look down and I see 6 grasshopper legs, how many grasshoppers would that be? Callie? So you do your thinking before you raise your hand, friend. I look down, I see my 6 grasshopper legs. How many grasshoppers would that be? Jordan?
There would be just 1 grasshopper.
There would just be 1 grasshopper. If I look down and I saw 6 grasshopper legs, that's only 1 grasshopper.
You only have 6 legs.
Because it's only 6 legs. Does that make sense?
Yes.
All right, let's try another one. Ready? Grasshoppers have 6 legs. No, we just decided that.
Yeah.
If you see a group of grasshoppers, or sorry, not if, you do see a group of grasshoppers. This time, you see 12 legs. How many grasshoppers are there? Addison?
Since 12 legs and 6 plus 6 is 12 and they both have 6 legs, that means it's 2.
Beautiful. Addison said, you know what? I know 1 grasshopper is 6. If I had another grasshopper, that would be 12 legs.
Write this.
No, you don't have to.
It looks like 2
Archer, thanks for raising your hand. That's okay. All right, you have a task. I'm going to let you work in partners for this task.
Yay.
Just because you are partners does not mean one person does the whole thing. Bo, and I'm tired of telling you to stop drawing pictures. These are your directions for the task. You're going to work in partners to do it. Please work together. Draw a picture. Challenge. See if you can come up with a bar model. That's a challenge. You'll see if you can try it. Make sure you're showing your work, because at the end, Cole, I'm going to have some groups share. And I want you to be able to share your thoughts. So make sure you're working with your partner so that you know how to explain it. When you finish your task, this is important, leave it on your desk, because you might be a group that is sharing. You're going to quietly move into your math choice board. Quietly, because some groups might still be working on their task. Don't bother other groups that are doing that. Are we clear?
Yes.
Partners for tasks. show your work, get your thoughts down. When you finish, you're going to put it on your desk and move to your math choice board.
We all finish our time.
Jordan,
Can I get you 2 for a burger?
absolutely not.